Derivatives of exponential functions. In this presentation, you will learn how to find the derivative of exponential functions. Let us first recall an exponential function. An exponential function is a function with a positive base b greater than 1 such that y equals f of x equals b raised to the power x. An exponential function with base 10 is called a common exponential function. An exponential function with base e is called a natural exponential function. E lies between 2 and 3 and is represented by 1 plus 1 by 1 factorial plus 1 by 2 factorial plus up to infinity. Let us now look at the properties of exponential functions. The first property is that the domain of f is R. The second property is that the range of f is R plus. The third property is that the point 0, 1 lies on the curve. The fourth property discusses the behavior of f of x. Case 1. When x is greater than 0, as x tends towards infinity, f of x tends towards infinity. F of x is an increasing function. Case 2, when x is less than 0, as x tends towards minus infinity, f of x tends towards 0. Let us now find the derivative of the exponential function e raised to the power x. Let f of x be e raised to power x. We know that the derivative of a given function is defined as limit h tends to 0, f of x plus h minus f of x whole divided by h. Substituting f of x plus h as e raised to power x plus h and f of x as e raised to power x, we get f dash of x equals limit h tends to 0, e raised to power x plus h minus e raised to power x whole divided by h. Here, e raised to power x is common. This expression can be written as limit h tends to 0 e raised to power x into e raised to power h minus 1 whole divided by h. E raised to power x is independent of h and limit h tends to 0 e raised to power x into e raised to power h minus 1 whole divided by h equals 1. This results in f dash of x equals e raised to power x. Let us discuss an example. Find the derivative of y equals e raised to power sine of root x. Let sine of root x be u. Then the given function becomes y equals e raised to power u. Differentiating y with respect to x, we get dy by dx equals d by du of e raised to power u into d by dx of u. Let root of x be v. Then dy by dx can be written as e raised to power u into d by dv of sine v into d by dx of v. This results in e raised to power u into cos v into 1 by 2 into 1 by square root of x. Combining the results, we get e raised to power sine of root x by 2 root x into cos of root x. In this presentation, you have learned how to find the derivative of exponential functions.